Okay, so there are 9 total possible outcomes. Right? So we have already known that they are independent events. Okay, so first we look at what is the probability of A happening. So meaning to say that the probability that the first ball is going to be red. So first ball being red, we have 1, 2, 3, 4, 5, 6. 6 out of 9 possible outcomes. Okay, then after the probability of B, which is that the second ball is actually green. So we have 1, 2, 3, 3 out of 9 possible outcomes. Okay, will actually give us the probability. And then after that, if I want to look at probability of A and B happening, that means the first ball must be red and the second ball must be green. Okay, and that will only be when these two happens. First ball red, second ball green, right? Okay, so we will have 2 out of 9 possibilities. Okay, so far you follow me about how I get these probabilities? Okay, so what I'm doing over here is to verify that this actually holds true. So probability of A and B is actually going to be equals to probability of A times probability of B. Okay, so if I were to take these two to multiply with each other, so if I take PA times PB, okay, I will be able to get 2 out of 9. Okay, if you press it into the calculator. Alright, so we will be able to see that. Therefore, when it comes to independent events, okay, probability of A times probability of B will be equals to probability of A and B. Okay, do you understand so far? Any questions? Do you need time to copy this down first? Because I want to erase part of it later. Okay, so this is for independent events. Done? I'll move on, yeah? Okay, so what if, alright, in the case whereby it's dependent events, so just now we said that dependent events is when there is without replacement, okay? Because if there's without replacement, when I pick one ball out, it will affect the total number of balls left inside the bag, correct? So my second pick will be affected by my first pick, okay? So if without replacement, we consider it as dependent events, so my outcomes will actually change, okay? Because if I were to pick the first ball to be red 1, I will definitely not be able to pick red 1 in my second pick. So this will change to become not possible. Right? Likewise, okay, if my first pick were to be red 2 and my second pick, okay, cannot possibly have red 2 anymore. So this will actually change to become not possible as well. Then after that, our first pick is green, my second pick can't be green anymore. So this will also change to become not possible. Okay, then my total number of possible outcomes in this case, instead of 9, it will change to 6 possible outcomes in total. Okay, then, so since the possible outcomes in total actually change, then my probability of A, B, and B will actually change as well. Okay, so probability of A in this case, which is first ball being red, it will be 1, 2, 3, 4, 4 out of 6. And then after that, the probability of B, which is second ball to be green, it will be 1, 2, 2 out of 6. Okay, and then after that, I find that the probability of A and B happening, which is first ball red and second ball green, okay, it will only be these two, so it is 2 out of 6. Okay, so it is coincidentally that these two are actually equal. Okay, but what I'm trying to say over here is not to say what probability of A and B is going to be. I'm trying to say over here that for dependent events, probability of A times probability of B, okay, will not give you the probability of A and B. You understand what I'm saying? Okay, so only independent events then you can get this multiplication, okay, that they are going to be equal. Okay, then after that for dependent events, alright, this will actually not happen. Understand? Okay, you cannot actually do it this way. So if come to dependent events, how do we actually do it? Okay, later on when we do more questions, I will talk more about it. Okay. So for now, we just understand that multiplication law is only for independent events, and addition law only happens for mutually exclusive events. Sorry, I'm 2 out of 9. Yeah, I'm saying it's not equal to 2 out of 6. It's 2 out of 6, right? 4 over 6 times 2 over 6 is what? 2 out of 9 lah. But it is not equal to 2 over 6 now. So not equal to probability of 8. That one. So yeah, correct. What is the issue? This is individual counting. Then I'm over here trying to multiply them together, and I show that this multiply together gives me 2 over 9. It is not equal to 2 out of 6. So therefore, dependent events, this theory doesn't work. Okay? Okay, so we'll move on into an example to practice about independent events first. Okay, so let's look at practice now 9. Okay, so the question says that there's some company, there are 2 departments. In that company, total 18 men, 12 women. In the tech department, there's 12 men, 4 women. Okay, so I don't want to write down the whole chunk of paragraph of words. Okay, so this would mean that if I were to calculate how many men would there be in admin department? How many? 6, right? And then how many women would there be? 8 women. Okay. So in this case, the chairman and the chairwoman are selected at random from the entire company. We want to find the probability that both the chairman and chairwoman are from the technical department. So the probability that chairman and chairwoman, okay, so when it comes to the word and, so earlier on I said that for union, okay, if we refer to all, alright, when it comes to and, okay, it means intersection now, okay, it means intersection. Sorry, I didn't use the symbol. Alright, but whenever you see and, okay, and in this case it's an independent event, okay, so the number of men that can come from the technical department will actually be 12 out of total of 18. And then we are able to multiply. So when you see n, you multiply. When you see all, you plus. Okay, usually that is the case. Okay. Then after that, chairwoman, there is 4 women from technical department out of a total of 12 women. So then the probability will be 2 out of 9. part 2, the probability of getting a chairman from the admin and the chairwoman from technical department. Okay, these are independent events. So in this case, what would the probability of getting the chairman from admin actually be? What's the probability going to be? 6 over 18, right? Then we multiply by the number of women that can come from technical, so that will be 4 over 12. So answer is 1 over 9. Question 2. Here we are given that the probability of laptop X breaking down is 0.1, and then for Y it will be 0.35. Okay, first part we want to find out what is the probability that both laptops actually break down. Okay, so sometimes the wording, okay, might not be very explicitly telling you that it is probability of laptop X and laptop Y breaks down. Okay, and then you see the end, you think of multiplying. Okay, so you need to understand that both laptop breaking down is equivalent to laptop X and laptop Y breaking down. Okay, so in this case, what will my answer be? 0.1 times 0.35, right? So that will be 0.035. Okay. Then after that, part 2, the probability that laptop X breaks down but not laptop Y. Okay. So that will actually be interpreted as laptop X breaks down and laptop Y does not. Okay, so we phrase this as and Y does not. So in this case, how would we calculate the probability?
0.1 times bracket 1 minus 0.35.
Okay, 0.1 times 1 minus 0.35. Okay, and that will give you 0.065. Okay, we need to do 1 minus 0.35 to find out what's the probability that laptop Y does not break down. Okay. Now for the last part, right, okay, slightly complicated, okay. We want to find out probability that laptop, exactly one laptop breaks down. So what are the situations that we're looking at? X break down, Y does not. Y break down, X does not. So you see, X break down and Y does not. Then after the next part, how do we link to Y break down and Y does not? How do we phrase this? Is the word over here going to be and or? Right? Okay. What's this kind of words called conjunction, is it? What is it in English?
So your X and Y will.
Oh, sorry, this one X. Okay, so it is looking at this probability. Okay, X breaks down and Y does not. Y breaks down or Y breaks down and X does not. Okay. So the first situation that we're looking at is X breaks down and Y does not. So X breakdown is 0.1 times Y does not, so that will be 1 minus 0.35. So this is the first situation. Okay. Okay. Then after that, because there is a or, alright, so what do we do? Okay, we have a plus, right? Okay, then after that, y breaks down and x does not. So y breaks down, that will be 0.35 times x does not, 1 minus 0.1. Okay, and that will give you 0.3. Yes.
Is it possible to find the probability that none of it breaks down, then 1 minus the probability that 2 breaks down minus 2 doesn't break down?
Okay, you said you want to find the probability that none of them breaks down, huh? Okay, maybe let's just do it together. Okay, maybe part 4, probability that none breaks down. None breaks down would mean what?
0.9 plus 2 times 0.65.
0.9 times 0.65. Okay, why not we just do a check whether that is true? How should we do a check? Okay, we multiply this, and then that will give us 0.585, right?